Hey everyone, I'm Derek Nyagudi, a mechatronics student at Dedan Kimathi University of Technology. And in this video today, we are going to talk about a hand-off automatic motor control circuit that lets a three-phase motor run forward or reverse in hand mode. So without too much ado, let's jump into the video. Getting into the video, we'll start with a brief introduction of our subject today. And we'll start by defining what a motor is. So a motor is an electrical device that is used to convert electrical energy into mechanical energy. And motor starting is the process of initiating the operation of an electric motor by applying power to it. Basically, what motor starting is like igniting the motor or turning on the switch of the motor so that the operation of the motor can begin. So why is motor starting necessary? So motor starting is necessary in the essence that it allows the three-phase motor to draw high starting current, typically 5 to 7 times the rated current. Again, high inrush current can damage electrical components and reduce system efficiency. So controlled starting helps protect the motor and the electrical work. And what are the motor starting methods? So we have 4 motor starting methods. The first one is the DOL. The DOL is basically the direct online starter. And we have the star delta starter. Third, we have the auto transformer starter. Auto transformer starter is basically automated from the transformer unit. And we have the soft starter. So defining the types of motor starting methods, we'll start with the direct online starter, the DOL. So the DOL is the simplest and the most common method of motor starting. It connects motor directly to supply of voltage. High starting torque and current. So application of the DOL starter, the first application is small pumps. The second is the fans and the compressors. The second method of motor starting is the star delta starter. So the star delta starter reduces starting current by initially connecting motor in star configuration. So star delta configuration are types of circuit connections that is talked more about in circuit network theory. So after a delay, it switches to delta configuration for full power operation. So application of star delta starter are conveyor belts, large fans, and pumps. We have the auto transformer starter. It uses an auto transformer to reduce a voltage during the startup. So if you're wondering what a transformer is basically a device that is used to control the amount of voltage in a circuit. It can either be a step-up transformer or a step-down transformer. A step-up transformer, it amplifies the voltage in the secondary coil, and the step-down transformer, it lowers the voltage in the secondary coil. So having known that, so we can say that the auto transformer the auto transformer starter uses an auto transformer to reduce voltage during a setup. That means that the transformer is in question is a step down transformer. So it gradually increases the voltage to full supply, and the applications of the auto transformer starter, it is used in large motors in industrial applications. The fourth one is the soft starter. So the soft starter uses a solid state electronics to gradually increase voltage. Again, it reduces mechanical stress and electrical surges. So application of the soft starter method is a HVAC systems and industrial machinery. So the types of connection we have the star delta circuit configuration, and this star delta circuit configuration, as you can see from the displayed image in the screen on the motor control system, this is how the star delta circuit configuration looks like before any connection is done. So after the connection is done, this is how the star delta circuit configuration looks like with the connections done, and this is how it should be connected. This is how it is properly connected. And another type of another component we have in the motor control system is the contactor station. So basically what the contactor station does, it electrically controls switches for motor connections. So the contactor acts like the main switch and has several switches that controls the motor connection. And then we have the overload relay station. So the overload relay station protects the motor from excessive current. It does this basically by breaking the circuit so that no current flows around the circuit. So it basically acts like a circuit breaker or a fuse. It controls the flow of current in the motor control circuit. So another component we have in the motor control circuit is the transformers. So the transformers reduce voltage during startup. That basically means that the transformer we have in the circuit is a step down transformer, since it reduces the voltage during startup. And then so moving on to the operation of the motor circuit. So the operation, how it works. So first, power is supplied to the starter circuit. So you can have an AC source or a DC source. And then the second one, the control circuit activates the contactor to energize the motor. So the control circuit activates the contactor by to energize the motor. And then the third one, in a star delta starters, a timer switches from the star to delta mode. And then 4, overload relay monitor current to protect the monitor. So basically, as we have said about the relay is like a circuit breaker. And then 5, if an overload occurs, the relay disconnects power to prevent damage. So the relay protects all the components of the system. And then in conclusion, these motor starting methods are crucial for efficiency and operation. So different starting methods suit different applications, and then proper selection ensures optimal motor performance and longevity. So that's it for this video, and thanks for watching.